Hello everyone and welcome to this week's fourth class, which is where we are basically discussing about the wastewater reuse and recycling aspect. Okay. So, in the previous lectures of this week we have talked about the different aspects of the wastewater reuse and recycling, starting from its basic concept and then what are the various types of the reuse, okay, what are the opportunities for reuse purpose, what is the scope where we can kind of reuse reuse or recycle the wastewater, okay, and those certain aspects that we discussed. So, this class we are going to talk about the regulatory guidelines, which is one of the very important aspects when we think of reusing the wastewater. So, that we are going to discuss in this class. So, while we go for the reuse purpose or recycling purpose of the wastewater, the major criteria or the most important aspect is to ensure that public health safety. Okay. And for the public health safety, we must understand that when we put water, like when we withdraw water from natural resources, process it and supply it. So, the water available in our natural resources are supposedly of like fairly good quality without too much of kind of pollutants which can cause severe health risk. But in the wastewater, because it is a used water, there has been lot of pollutants added from the households, or if it is industrial wastewater from industrial sector. So, because of this inherent availability of the various contaminants or various pollutants in the wastewater, there is a much superior degree of health risk. And for the treatment aspects that we see, so our secondary treatment does not target removing of all those contaminants. Okay, we may go for advanced treatment, but for that purpose also we have to have the idea or detection of what kind of contaminants are present in the wastewater. So, if we see those considerations of the different types of water quality consideration, so there is physical water quality consideration or physical contamination which is due to the physical contaminants, which could involve turbidity, color, suspended solids, etc. Then there are chemical contaminations in the form of organic pollutant, metal, nutrients, biological contaminants which are pathogens and could be algae or those kind of thing. So, up to these are pretty okay, people know that these will be present in the wastewater and they provide adequate degree of treatment if they plan to for reuse or recycling purpose, that is done. The most threatening or most dangerous is the emerging contaminants, because the emerging contaminants are the compounds which has not been traditionally like detected or formulated. So, there are not many reuse guidelines on these emerging contaminants, okay, and people generally do not go for testing these at first place. So, if you are not testing that your wastewater, does it have pharmaceutical or personal care products, does your wastewater has pesticides in it, does your wastewater has say various industrial contaminants, okay, there are many endocrine disrupting compounds. So, are some of them present in the wastewater. So, if we are not testing that at first place, so we do not know if there are emerging contaminants exist or not, and probably we will end up supplying a water saying that okay, it is not having BOD, it is not having COD, it is not having suspended solids, the dissolved solids are also not too much, okay, all within the permissible limit. But if you have not tested for these emerging contaminants at the first place, your water may not be safe for the reuse purpose. So, that is how the public health security becomes much more prevalent with the recycled or treated wastewater supplies or reuse options as opposed to the raw water reuse systems. Okay. So, depending on the end use category, there are like various examples of the emerging contaminants or the newer pollutants which are coming these days. So, in industrial chemicals we can have dioxins, we can have a kind of various tetrachloroethene or those kind of things. then there is possibility of pesticides, biocides and herbicides coming in. Okay. So, atrazine, linden, chlorpyrifos, endosulfan, those kind of compounds could be present. There are natural chemicals, so various hormones, okay, the growth promoters, okay, weight, these things. So, there are like quite a few those kind of things can be possible. There are various pharmaceuticals and metabolites in the form of say antibiotics, analgesics, then beta blockers, okay, so anti-allergics, so then oral contraceptives. So, there are like variety of these things can also be present. There are various personal care products, okay. So, a lot of cosmetic comes under this category, fragrances, cosmetics, pigments, those kind of things. There are variety of household chemicals and food additives, okay. So, again quite a few food additives are being used in these days by people, and various transformation products. So, the original products when they get transformed in presenting in the water through hydrolysis or those kind of systems. So, they may be like trihalomethanes, haloic acids, so those kind of things could be present in the water. So, they are the kind of things that are most crucial, and that is why when we go for reuse quality characterization or reuse quality standard, we must think of the potential risk that these compounds could cause and the chances of these compounds being present based on the point or the source of the wastewater that we are discussing with. So, if our source of wastewater is industrial wastewater, then there is a like significant chances of some of these being present over there. Okay. So, that is what is the basically one of the important aspect that one must consider while going for the wastewater reuse purpose. So, if we see that regulatory reuse guidelines, so there are international guidelines and there are various country specific guidelines or nation specific guidelines. So, in international guidelines, like we have agencies such as WHO which releases its guidelines, there are European Union which has its own like reuse guidelines, there are nation specific. So, for different countries there are different guidelines. It is not available for all countries. So, like India does not have reuse specific guidelines as of now. So, like the discussions are on and people are like saying that we must have a reuse water reuse quality standards, but as of now it does not exist. So, but there are various countries that have like there are guidelines from Australia, Jordan, Turkey, those kind of countries does have their own guidelines. US of course has, so federal water reuse requirements or USEPA has its own guidelines. There are state level requirement and guidelines also there in the various states in a nations, like in Australia we have guidelines from Victoria, guidelines from South Australia. In US we have say the like California has its own guidelines. So, there are variety, like the different states could have their own requirements, their own recommendations and their own guidelines for waste, because water being a state subject. So, they can like the different states can come up with their own guidelines also at many places. There is possibility of other guidelines. So, some even the municipal state systems could make those guidelines, revise those guidelines, make them more stringent or more relaxed or make more situation specific. So, if we see the WHO guidelines, WHO has kind of a like they prepare a 4-volume manual on these guidelines for safe use of wastewater, excreta and grey water. So, that there were the 4 volumes of this was released which are available online, and the volume 1 dealt with the policy and regulatory aspect, volume 2 dealt with the wastewater use in agriculture, volume 3 was wastewater and excreta used in aquaculture, whereas volume 4 excreta and grey water used in agriculture. So, these were the 4 different volumes which kind of in detail, almost each of these are for over 200 pages. So, they in kind of detailed explained and summarized the various potentials, risk associated, reuse aspects, okay, in all these 4 different volumes from the WHO. So, these WHO guidelines essentially are kind of integrated preventive management framework, okay, for maximizing the public health benefits of the wastewater, excreta and grey water uses in the agricultural and aquaculture. The guidelines are built around a health component and implementation component. So, there are health components, so risk associated or how to establish those risks, how to ascertain that these risks are minimized. So, all those are described in quite detail in these guidelines, and there are then implementation components. So, how to implement these systems for the reuse or potential reuse in the agriculture and aquaculture, those kind of systems which are the prime focus for these WHO guidelines. So, health protection is dependent on both the elements. So, health component kind of talks about establishing a risk level between the associated with each and identified health hazard. So, what is the risk associated with the different health hazards that are there, and then it also defines a level of health protection that is expressed as a health based target for each risk. Then it identifies these health protection measures. So, what different measures we can adopt collectively, say, for protecting this health. Okay. So, that way the idea is to achieve the specific health based targets, and then in the implementation components it establishes monitoring and system assessment procedures. So, how to monitor these like this effectiveness of these systems and the risk arising of these systems. Then it also defines the institutional and oversight responsibilities. So, how these different institutions can actually be made responsible for the different tasks, okay, how the responsibilities can be shared or distributed among the different stakeholders, different institutions looking after the case. It requires system documentation. So, what kind of system documentation is required is explained in this implementation component, and it also explains the requirement of the confirmation by the independent surveillance. So, there has to be like it is not, because mostly water is a state subject. So, the government are responsible for looking after, taking after these things, or even if it is, let us say, outsourced to some agency. So, there has to be independent surveillance also in order to make extra sure that the risks are minimized and things are being implemented in fair and proper manner. So, this is another like kind of WHO guidelines for different type of reuses. So, what are the criteria for pH, TSS, TDS, turbidity, BOD, those kind of things. So, I am sorry that numbers might not be apparently visible, but the idea is that there are such systems exist which can be used for the purpose of seeing that to what scale treatment is needed based on my target reuse criteria. Okay. So, like if we say the designated wastewater reuse criteria and standards from USEPA or USAID guidelines, if we see. So, they are depending on the type of reuse. Again, if it is for urban reuse, so the degree of treatment needed, secondary filtration and disinfection, the reclaimed water quality should actually be meeting this, and we need to regular monitoring of the like weekly monitoring of the pH, BOD, turbidity should be continuously monitored, chlorine residual should be continuously monitored, and coliform or pathogen monitoring should be on a daily scale. Okay. If it is being used for, say, agricultural reuse, for food crops not commercially processed, so food crops that are not commercially processed, so there are secondary filtration, secondary stage treatment, filtration and disinfection is needed, and this is the kind of like reclaimed water quality. It should meet this quality. So, pH should be somewhere between 6 to 9, the BOD should be less than 10 milligram per liter, turbidity should be less than 2 NTU, there should not be fecal coliform detected, okay, and the residual chlorine should be 1 milligram per liter minimum. again we need to monitor these, so coliform on daily scale and those few parameters on weekly or continuous scale. Then if it is for agricultural use for food crops which are commercially processed, so again we need to go for secondary and disinfection level treatments. This is the minimum requirements, okay, and these are the monitoring requirements. And if it is being used for non-food crops in agricultural, so again we will need secondary and disinfection, secondary treatment and disinfection with these water quality criterias, and these are the monitoring requirements. So that way we have these different like criterias and requirement for monitoring, okay. So WHO has then other similar like guidelines for other prospective as well. So there is a microbial quality guidelines for wastewater reuse in agriculture. So there are 3 categories specified by the WHO. So reuse condition is for irrigation crops likely to be eaten uncooked, okay, like sports field, public parks, those places. So the exposed group is the basically workers, consumers, public, okay. There has to be like the intestine nematodes measurement, so basically no X per liter less than 1, okay, fecal coliform less than 1000, so this is geometric mean. For B, which is irrigation of like cereal crops, industrial crops, fodder crops, pasture and trees, so the workers will be exposed to this. There is no recommended standard for this, and for intestinal nematodes should be less than 1, and localized irrigation of crops in category B if exposure of workers and public does not occur. So if it is not there, then nobody is actually going to expose with that, and there are no kind of these things are not applicable. So this is the recommendation from WHO, okay. Similarly, we have say recommendation from various other agencies, like Food and Agricultural Organization of states, those places. So like there are trace metal standards for irrigation water. So for water being used in a irrigation, these are the standards for various trace metals. So for say aluminum should be less than 5 milligram per liter, arsenic should be less than 0.1, beryllium less than 0.1, boron 0.75, that way zinc 2, okay, lead could be up to 5, iron could be up to 5, fluoride could be up to 1 milligram per liter. So that way we have various standards for these different metals, and then of course in what way they are kind of this thing, like copper is toxic to a number of plants at concentration 0.1 to 1 milligram per liter, but still like up to 0.2 is okay, that what has been recommended. Cobalt is toxic to tomatoes at 1.1 milligram per liter, so tend to be kind of inactivate by natural and alkaline soil, so that is why it is just 0.05 is the recommended limit. So what kind of effect they can create that way, okay, and what is the allowable permissible maximum concentration level is mentioned over here. Similarly, if we see that kind of microbial standards for various non-food crop irrigation, so then again there are different state and countries. So like from Puglia in the Italy, it's less than 10 coliform, total coliform should be less than 10, okay. Fecal coliform is not mentioned over there. For California in Italy, it should be less than 23, Australia fecal coliform less than 10, Germany fecal coliform less than 10, and total coliform could be less than 100, okay. In Florida it is 200. So WHO, if you see Greece or Spain standard says less than 10,000, okay. So that way there are like the different standards for the different states or different countries that way. Now in agricultural sector there are various operational considerations are also kind of thought about. So the like compatibility of the agricultural operation with reclaimed water may be kind of needed and may be evaluated from the site specific investigation, okay, and that is how this compatibility issues may be seen, and it should be ascertained that the water supplies like the reclaimed water which is being used is compatible for that particular agricultural operation. Okay. So, it depends again on the suitability of these things, like for example, the reclaimed water treated with the secondary level may not be suitable for a drip irrigation system. Okay. So, why it may not be suitable for a drip irrigation system? Because secondary level treated water may still have certain suspended solids. So, those suspended solids can actually create problem in the drip irrigation system, can block the nozzles or those kind of thing. So, there is a high risk of increased clogging in such scenarios, and that is why it is not recommended. Okay. There are differences in agriculture and municipal system reliability requirements as well. Okay. So, for say like municipal systems are supposed to be more reliable as opposed to the agricultural system. Okay. So, if you are having, let us say, a pump which is pumping water in a municipal system and you get your pump fail at certain stage, so municipal supply is going to be stopped, which is totally not acceptable. So, you will have to have the backup pumps, okay, installed in a municipal system, but in agricultural system it is not that essential. So, it is not that like you have to keep extra backup pumps for pumping water in agricultural system. So, we can sort of like see what scale or what level of reliability is needed. So, even if let us say your pump goes off for a day or couple of days, it is not that your food your crops is going to be die immediately. So, of course, you can basically arrange in between. So, putting just extra pump or putting those kind of redundant features for large amount of time unnecessary lying is not advisable, because that will have associated financial cost. Okay. So, further, the reclaimed water quality is directly linked to the crop, okay, that may be produced with that water, and that is why there are need of additional regulatory controls, okay, that detect the irrigation water that is basically being used. So, as we have been discussing, that there needs to be regulatory controls that includes modification to the irrigation system and prevent contact with the eatable crops particularly. Okay. Then it may also be undesirable to use secondary quality reclaimed water where irrigation equipment result in aerosols, okay, again because of the issues. Okay. Then there are regular communication between the end user and reclaimed water supplier is critical for a successful program. So, that user must be aware, all the stakeholders must be aware with this issue. So, it allows that issues to be addressed as and when they arise in the immediate basis. So, these are some of the operational consideration. Now, if we see the design designated wastewater reuse criteria and standards for other stuff. So, for irrigation water quality interpretation, okay, based on the quality of the treated water. So, if let us say this is the quality of the treated water, wherever it falls, we can say that how it can be used. So, if this quality is say in this range, so that water can be used without any restriction. Okay, it can be used anywhere. So, salinity being less than 0.07, TDS being less than 450, okay, the SAR being less than 3 means the sodium adsorption ratio that way, okay, chloride being less than 4 in a milliequivalent per liters. So, with these nitrates less than 5, bicarbonates less than 1.5, this water can be used anywhere without any issue. If it falls in this range, so it can be basically there might be slight to moderate restrictions of using that water. So, let us say the restriction could be in the form of that use it for only for like non-contact food crops or those kind of thing. But if it is greater than these ranges, so there could be severe restrictions that okay, this water should be used at non-contact places or should not be used for say food crops. So, those kind of severe restrictions can come in picture with the quality of the treated wastewater which is available for irrigation or reuse purpose. There is a industrial reuse options is also there. So, for example, so this is the recommended boiler water limits. Okay. So, if you want to put water in the boiler, the TDS is almost one of the very important criteria for boiler purpose. Okay. So, for boiler water the TDS has to be in this range, okay, and alkalinity in this range. So, again at what pressure it is being operated. So, if it is being operated say under you can take any, like if it is operated under this pressure. So, these are the criteria that should be there. If it is being operated at higher pressure, so these are the criteria it should actually meet or it should fulfill. So, that way we have kind of again as we were just discussing that there is we are not too much interested in these values. It is just to give an idea that yes, these kind of restrictions or these kind of limits or quality standards exist, and once somebody is planning for a reuse option, so he must ensure that the water quality that he is producing or the reclaimed water quality that is there should actually be appropriate or should meet these regulatory requirements, should be good enough for that water to be used for the designated purpose what we are discussing. So, just a quick recap that US EPA has these different categories of the reuse, and for these different reuse categories they have a category wise guidelines which they have suggested. So, for say urban reuse option, if you see, okay, so unrestricted urban reuse option, they say that these could be the recommended treatment level and these could be the guidelines. So, some of these as we were seeing earlier, and then what is the setback distance, means that distance minimum should be maintained this much, so that it actually does not affect the system in a larger run, and then there are various observations and comments over there. Similarly, for agricultural reuse for food crops, these are the criteria. For processed food crops, non-food crops, these are the criterias. Okay. So, that is about the urban and agricultural reuse. If it is going to the impoundment, so these are the again it should meet these criterias. Okay. This should be the monitoring frequency, the setback distance should be this much. For restricted impoundments, again a secondary level secondary level treatment and disinfection is going to be good enough. These would be the reclaimed water quality monitoring frequencies, okay, that way. For environmental reuse purpose, this is little variable, as they say it is variable, but should not exceed to these limits. Okay. Similarly, for like the monitoring should be for BOD, suspended solids, fecal coliform and chlorine residual. Okay. For industrial reuse, so here we do not have any setback distance because we are anyway releasing in the environment. In the industrial reuse, then for cooling purpose secondary treatment is good enough. So, we can have a relaxation for the water quality as well. Whereas, for cooling towers, recirculation cooling towers, for secondary after that we need disinfection. So, this kind of this thing and this the monitoring. For other industrial purpose, like there are again specific requirements for groundwater recharges, okay, which is for non-potable uses. So, it is basically site is specific and user is specific, it depends on the usage. So, what way we want to kind of like recharge systems, which system we want to recharge, it will all depend on that. Then for the indirect potable uses, okay, the IPR systems, so it has to be basically meet these quality criterias. Okay, the quality criterias are going to be little more stringent there, and the reclaimed water should be monitored for variety of parameters including pH, total coliform, chlorine residual, drinking water standards, and various other parameters including TOC, turbidity and metals or those kind of things should also be monitored. Okay. Same degree of monitoring is required for here if we are going for a groundwater recharge for potable aquifers, or if we are augmenting to the surface water reservoir for potable aquifers. Okay. So, this is the kind of requirement that is needed if it is going for DPR, direct potable uses. So, obviously, it should meet the potable quality requirement of the potable water quality requirement or drinking water quality standards, which is there in the which is applicable for each respective supply utilities or in the different countries, the different standards that are there. So, these are the kind of standards that should be followed when we go for the, when we plan for the wastewater reuse or recycling projects, okay. And these standards are set based on certain criterias, which kind of the major objective is to ensure the safety of human health and environment, okay. So, with those ideas, these standards have been set from the different regulatory agencies, and they vary actually from place to place. So, one country may have certain standard, another country may have maybe a little relaxed standards or those kind of, or maybe stringent standards. So, those things are there, but the regulatory requirements suggest many countries do not have reuse standards, like we gave the example for India, but still in those countries the direct water supply standards should be used for reuse purpose that way. So, that is about the regulatory aspects, okay. So, these are the kind of standards that your wastewater or that the wastewater treatment facility should meet if the intended use or intended target is reuse or recycling of the wastewater. So, we conclude this lecture here, and then in the last lecture of this week we will discuss the kind of some other aspect related to the waste related to the recycling, okay. So, the scale of recycling and those things we will be discussing in the next class. So, see you and thank you.